All right, in this problem here, we want to solve for x, and x is up in my numerator, not numerator, in my exponent in this power equation here. So at first look, this kind of seems like a tricky equation because I'm not really sure how to find this x. And so recall, if I were to have two exponents or two powers in a similar fashion like this, where I have the same base, if I have 5 to the x is going to equal 5 to the second, well, it must make sense that this term is also 5 to the second. So when I have the same base, I can set my exponents equal to each other and solve for x in that way. So I'm going to actually use a similar strategy with this problem here. And as at first glance, we notice that these bases are not the same. I've got 3 to this power and 243 to, I guess we could just say that's the first power. So I have to be a little bit clever here, and I have to remember that that 243 is the same thing as 3 times 3, that's 9, 27, 81, and there's my 243. So this is 1, 2, 3, 4, 5, 3 to the 5th power. So we have to be a little bit clever with ways that we can express these numbers as their powers. All right, so now I can rewrite this as 3 to the 1 minus 2x power is going to equal 3 to the 5th power. And what do you know? Now I have the same base. That's good. And I can set my exponents equal to each other. So 1 minus 2x must equal 5. And I can rearrange my equation a little bit, subtract my 1. I get a negative 2x equals 4, and divide both sides by negative 2. So I get x should equal negative 2. Now we could also check that by plugging that back into my original equation. So this would be 3 to the 1 minus 2 times negative 2 power should equal 243. And this looks like it's coming out of 3 to the 5th, and that does equal 243. So that checks out. And that's how you solve this guy.